Mr. Pythagoras. So what's the Pythagorean theorem? What do we? Okay, so all of today's identities are related to a squared plus b squared equals c squared. And remember, that was a right triangle. So let's rewind, think about the unit circle. That's a pretty good unit circle for my first circle of the day. There's the angle, the x distance, the y distance, the r distance. Okay, so what would Mr. Pythagoras say about that triangle we have in there? How would we lay a squared plus b squared equals c squared? How would we use that on this triangle? Okay. X squared plus y squared equals r squared. In the unit circle, do you remember why we called it the unit circle, the 1 unit circle? Because radius is 1. Okay, so we could replace r with 1 squared, which is just 1. And how about that x coordinate, right? It was x comma y, but that also, it wasn't just the x coordinate. What did the x coordinate tell us about the angle? Cosine. And the y coordinate was sine. So in place of x, we could put cosine of theta. And in place of y, we could put sine of theta. And if we wrote that a little bit differently, cosine squared plus sine squared equals 1. That's our first Pythagorean identity. And for whatever reason, even though it comes from x squared plus y squared equals r squared, almost everybody remembers it as the other way around. Sine squared plus cosine squared equals 1. I mean, those are identical, but most people remember it with the sign first. That's our first of 3 Pythagorean identity. That's the first and the main Pythagorean identity. And I guess you figured this out, but most of the times when we learn a formula in math or science, it's like, all right, you use it for this unit, and then if you need it, you just go look it up, because you can't remember all the formulas for everything all the time. Like, that's a little bit ridiculous. But this is one of those that needs to be at the forefront. All right, kind of like the quadratic formula. I hope you still know what that is. This needs to be up there with formulas I remember, because you'll need it a lot today, but not just today. In calculus we use it. So this is a big one. Sine squared plus cosine squared is 1. Now there's 2 others, and depending on your favorite method, you can spend 2 pages coming up with the others, or you can spend 2 lines coming up with the others. I assume you'd rather spend 2 lines coming up with the others rather than the 2 pages. So the 2 others, one way to get the other one is to divide by sine squared. So I'm going to start with, in fact, this is how I remember the others. I do not have the others memorized. I know this one, and I know how to get to the other ones. So I'm going to start with sine squared plus cosine squared equals 1. And to get my second one, I'm going to divide everybody by sine squared. And again, every year I need these, I have to do this to come up with the other two. I really do not remember what they are. I just know how to get there. What's sine squared divided by sine squared? 1. What's cosine over sine? Cotangent, so cotangent squared. And 1 over sine? Cosecant. So there's our second one. I box it, but I don't even know that I would box it in terms of what to memorize. What you memorize is how to get it. At least that's what I do. I'm not going to memorize all three of these. I definitely know sine squared plus cosine squared is 1. After that, I'll divide by sine squared to get one of the others. Any guesses on what we do to get the third Pythagorean identity? Let's divide by cosine squared. So start with the original. Divide everybody by cosine squared. And I can pick on some people. Landry, what's sine over cosine? Tangent. Angel, you get the easy one. What's cosine over cosine? 1. Gregory, what's 1 over cosine? So you were on the right track. Secant. So there's the 3 Pythagorean identities. But again, I do not memorize all 3 because I got the first one down. After that, it's like there's tangent, there's secant, there's cosecant, like who's paired with who, where does the plus 1 go? Like, there's all sorts of, there's 2 pages worth of mnemonic devices to help you remember, whatever. Look, there's tangent and secant holding hands because they're friends, and there's cotangent and cosecant. And I don't know. Just start with this one. Divide by sine squared, divide by cosine squared. So at the start of the next test, what you'll probably write at the top is sine squared plus cosine squared is 1. And then some of you won't even write this. You'll just look what happens when I divide by sine squared. I get 1 cotangent and cosecant. And if I divide by cosine, I get tangent and 1 and secant. So to me, I don't want to memorize all 3. Definitely got to memorize the first one. And then you're just dividing by the first thing and dividing by the second thing. If you want to memorize all 3, that's fine. It's just people get mixed up on, where's the plus 1 go and who's paired with what. And it's like, don't. Just take the, 10 seconds it takes to divide by each of those to get the 3 Pythagorean identities. If you want to borrow the notes to copy down all the extra stuff, you're welcome to it. But I suspect, I'm biased, but I like this method better. Now, we do need to be careful because sometimes we use these in a little bit different way. Like we need to be able to manipulate them. Here's what I mean. Like cosine squared is 1 minus sine squared. Right, but that's not a different formula. That's just rearranged. And sine squared is 1 minus cosine squared. Whoops. X and theta. It doesn't matter which one I pick, but it needs to be the same one. And occasionally you might even see sine squared minus 1. So can you rearrange this formula to know what sine squared minus 1 would equal? If I rearrange this, move the 1 over here. I have to move the cosine to the other side. So it'll be negative cosine squared. And same thing with cosine. Cosine squared minus 1 would be negative sine squared. But these, don't memorize those. Just be aware that sometimes you have to move things around to get what you want to get. Same thing with the others. I'm not going to write down every possibility for each of them. But that means, like, I'll just write down one of them. Cotangent squared. What does cotangent squared equal? JD, what does cotangent squared equal? If I just rearrange this formula to solve for cotangent squared.
Cosecant minus 1.
Good.
Or
Cosecant squared minus 1. And if I rearrange this last one, Luke, to solve for secant, no, it's already solved for secant. To solve for tangent, I rearrange this to solve for tangent. Secant squared minus 1. And so this sort of further illustrates why you don't want to memorize these, because you can get the ones and you can get things mixed up too easy. Sine squared plus cosine squared is 1. Divide by sine squared, divide by cosine squared, and then be able to sort of move things around to get what you need. Let's do some examples. Some of the examples are show examples, meaning we give you the answer. Others are like simplified and just see what you get. Show that sine of x plus 1 times sine of x minus 1 equals negative cosine squared x. Well, what do you think we should do with the left-hand side there? Let's FOIL it. So sine squared minus sine of x plus sine of x minus 1. Well, as always, when we FOIL conjugates, the middle stuff goes away. And I'm left with sine squared x minus 1. I don't have every iteration of that formula memorized. All I know is that, so out to the side I write, just kind of note to self, sine squared plus cosine squared is 1. So can you mentally rearrange this to know what sine squared minus 1 equals? Well, I guess at this point, yes, because we already know the answer. Sine squared minus 1 should be negative cosine squared. Right. If I rearrange this formula, if I move the 1 over and move the cosine over, sine squared minus 1 is negative cosine squared. Number 2, show that tangent squared minus secant squared over cosine squared is equal to negative secant squared. Okay, I seem to remember there is a Pythagorean identity with tangent and secant in it. So I go, and again, I don't have this one memorized, but I have it written at the top of my page whenever I'm doing these problems. Tangent squared plus 1 equals secant squared. So what does tangent squared minus secant squared equal? Can you rearrange this to make it say tangent squared minus secant squared? It equals -1. I move the secant squared over, I move the 1 over, and so that top is -1. And then I'm there, because now 1 over cosine is secant. There's also a negative on there. Negative secant squared x. So again, today's worksheet, have those 3 things, 3 Pythagorean identities handy, and know how to move things around. I would not write every possibility out like I did. Like, just know that sometimes you got to add and subtract things to get the format that you like or that you need. Another show problem. Cotangent squared x plus 1 over secant squared x equals cotangent squared x. Okay, cotangent squared plus 1. That looks like a Pythagorean identity. I've got to go peek and see what it was. 1 plus cotangent squared is cosecant squared. So if 1 plus cotangent squared equals cosecant squared, what does cotangent squared plus 1 equal? That's supposed to be the easy question, because all we did was change the order. So that's still cosecant squared. So all of this is cosecant squared. And somehow that's supposed to be cotangent. I think I want to change this into sines and cosines, because then I'll recognize cotangent, hopefully. Let's see, cosecant is 1 over sine squared. Secant is 1 over cosine squared. And then if we'll keep it, change it, flip it, I think everything will be in the right spot. To be cotangent squared. So pretty similar to what we did yesterday. In fact, using what we did yesterday, but also adding the Pythagorean identities. Too fast? Good?
Yep.
Number 4 is going to be a multiple choice question. So yeah, usually we like multiple choice, but when the other option is having the answer given to you, I guess we'd rather have the answer given to us. Cosine x times tangent x plus cotangent x equals either secant or cosine or cosecant or sine. That one's not at all obvious to me which one the answer is. And nothing squared, so don't try to use, people try to use those Pythagorean identities when there aren't squareds on them. If there's not squareds, you don't get to use those, right? You don't get to say, oh, let me just square root all the pieces and sine plus cosine is 1. Please don't do that, right? Way back here when a squared plus b squared equals c squared. If you could square root those and make it easier, then why would we memorize it this way? Why wouldn't we just say a plus b equals c, right? So you can't go square root the pieces. So if there's no squareds, you're not even eligible to use Pythagorean. So no Pythagorean yet on this one because nothing's squared. So thoughts on what else we could do? Jake?
You make the tangent and cotangent, and you like put them in the cosine over sine and sine over cosine.
I like that. Like whenever you're stuck, that's always something you can do. Change everything to sines and cosines and see what happens. Okay. Well, the first one, if we distribute the cosine, the first one will cancel out and you'll be left with just sine of x. So that's nice. But the second one, the second term, what's that going to be? Cosine squared over sine. Yes. So that was great news on the first term, not so great news on the second term.
Well, like in the parentheses, could you not just like cross out both sides and that's the one? And then just multiply?
So you want to tell me that x over y plus y over x, you want to cancel the...
Oh, that's plus.
Yep. That's a plus in there. Yeah, if this was multiply, we could have stopped right back here and tangent times cotangent would be 1. But it's addition, so... Okay, the next step is maybe kind of tricky, and you have to have done a few of these probably to figure out where we're headed. But I look at my answer choices, and my answer choices all have, like, they're just one thing. So I know I can't have two pieces to my answer. It's got to somehow simplify to one thing. So if I want to simplify or combine two fractions into one that are adding, what do I need to do if I want to actually add the two fractions? I need a common denominator. What's my common denominator going to be? Sine. So I guess that's not the greatest common denominator in the world, but that's not the worst either. So sine squared plus cosine squared. We have a common denominator, so I'm going to write that all over sine. Now, it may not be happening yet, but eventually alarm bells will be going off in your brain, because what can we do next? Sine squared plus cosine squared is 1. So anytime you see squareds involved, you should be thinking, I got a Pythagorean identity here. And then 1 over sine of x, that's the same thing as cosecant. So sort of the key point of that problem was you need a common denominator to add fractions. Now, you know that already, but we haven't done that with sines and cosines. So that's one of the, we're basically going to see some techniques that we can use today, and that's one of them, get a common denominator. Number 5, sine cubed of x plus sine of x cosine squared of x equals, this will be another multiple choice question, either sine squared, tangent squared, cosecant, or sine. Any thoughts on what we could do first with this? Let me ask again, any thoughts on what we could do first with this? Well, not really combine, because they're not like terms. I could. Both of them have a sign in them. So I could take out a sign and put the sign out front. So, Evan, if I take a sine away from sine cubed, what needs to be the first blank in my factor here? Sine squared. Noah, if I take sine off of sine times cosine squared, what goes? Cosine squared. And then, again, alarm bells should be blaring in your head right now, because sine squared plus cosine squared is 1. And so there's our answer, sine of x. So there's another technique, is to factor things out if you can. All right, last one. If it on my page or not, but we'll give it a go. Sine of x over 1 minus cosine of x. And leave some space here, because we're going to do something here. This is a show problem, so I'm going to give you the answer. Equals 1 plus cosine x over sine of x. This is one that you probably wouldn't get unless your math teacher showed you what to do. Well, when you're showing, that means you can only work on one side. So cross multiplying would work. Like you'd have sine squared on one side, on the other side you'd have 1 minus cosine squared, and yeah, those would be the same. But I only want to work on one side. So good thought, it works, if we were allowed to do it. So here's the trick. We're going to multiply the top and bottom by the conjugate. So that's sort of our last technique that we can use. Multiply top and bottom by conjugate. So the top I'm just going to leave alone, because the reason I'm multiplying by the bottom is I'm going to get 1 minus cosine squared, and that becomes a Pythagorean identity. So let's leave the top alone for right now. That's kind of a mess, but the reason we did this was to get something nicer in the bottom. 1 minus cosine squared. Okay, alarm bells, because that's a squared term, so that's Pythagorean. So out to the side, I'm thinking sine squared plus cosine squared is 1, which means that 1 minus cosine squared is equal to positive sign or negative sign?
1 minus cosine squared is equal to what?
That's my question.
Yeah.
1 minus cosine squared.
That was your question.
That is my question. 1 minus cosine squared. If I rearrange this to get 1 minus cosine squared, what does 1 minus cosine squared equal? Sine squared. So in place of 1 minus sine squared, I'm going to put, in place of 1 minus cosine squared, I put sine squared. By the way, start peeking at your answer if you haven't already. This is good news, right? What's left to do? Yes? Cancel one of the signs. And then you've got your answer. 1 plus cosine x over sine x. Okay, so we got a bag of tricks today. The Pythagorean identities. But then also some of these other things. If you need to combine two fractions into one, it takes the common denominator. Sometimes you can factor. Sometimes multiply top and bottom by a conjugate. These are usually pretty easy to spot, by the way. Well, in fact, let's look at worksheet number 2 and see if we can spot the conjugate problems. They're usually on the Look at page 2. So where do you see conjugate issues probably going to show up? Well, number 10 already is a conjugate, so we multiply that out and see what we get. But then 13 and 14, the only way that's going to fix is if I multiply top and bottom by conjugate. Same with 14. I'm going to fix that by multiplying top and bottom by conjugate. All right, so we've added to our bag of tricks, but we still need to use the ones that we already know. So today's assignment, worksheet 2, definitely try some of those so that we can go over them tomorrow.